Hi there, this is your favorite math learning channel, and I have a serious problem for you. So let's see how we can do it. Well, it actually looks really complicated. So I have cosine cube. Maybe if I make it cosine, it may be a bit easier. So let's see how can I do that. So basically, I'm gonna use De Moivre's theorem. This is really useful. So I'm gonna use it to find that, for example, in the end, I will see something like cosine cube x is equal to something cosine, maybe something sine, cosine x, cosine 3x. It will be in this form. And you can do it for any power of cosine or sine. So let's see what this is. So there is a theorem that says cosine nx plus I sine nx is equal to just cosine x plus I sine x to the power of n. This is really useful theorem, and it can be like if you know the polar coordinates, it's so trivial, but in general it's not. You can also prove it by induction. This is really important. Okay, so we are gonna use this. So since I want cosine just power of 3, I can just pick n is equal to 3. So if I pick n is equal to 3, this thing is gonna be, so this is when n is equal to 3. This thing is just gonna be k is from 0 to 3. I have cosine x, I sine x, and I also have just 3 chooses k. So what will I find is that, so I picked n is equal to 3, I will have this stuff, cosine 3x plus I sine 3x is gonna be equal to just this stuff, and I can open it. So if I put k is equal to 0, I also have this powers, let's say n minus k and k. If I put k is equal to 0, it will be, so let's say this is just 3. So it's just gonna be cosine cube x. If I actually pick k is equal to 1, I will get imaginary part. So basically what I want is that I only want to keep cosine cube x, and this is real. So I can only check the real parts, because adding up all of the real parts here is going to be equal to cosine 3x, and all of the imaginary parts are going to be equal to sine 3x. So I can only check the imaginary one, or I can only check the real ones, and it will be enough for me. So if I put k is equal to 2, it will be cosine x. And this is going to be I squared sine squared, and I squared sine squared is going to be just minus 1 minus sine squared. So I can also make this minus, and I also choose 3 chooses k, which is just 3. 3 chooses 2 is 3. 3 cosine x sine squared x. Okay, cool. I also have some I terms, but I don't care about it, because now I know that this stuff is equal to sine 3x, and this real stuff is equal to cosine 3x. So now I can just leave cosine cube x alone, because it's what I want. Cosine cube x is equal to cosine 3x plus this stuff. And for this stuff, so maybe I can get rid of this sine squared by just saying sine squared is just 1 minus cosine squared. And I can group them, and I will get another cube. So it's actually enough for me, because if I do that, I will have, so this will be plus 3 cosine cube 2. So this will actually be 4 cosine cube x. And then I will have minus 3 cosine x from here, and this will be just plus 3 cosine x. So that's it. Like, till this part, this was my goal. I found another expression to show what is cosine cube x. So now let's look at my problem. I need cosine cube of some stuff, and so this is just like I found it for x, but I need it for 3x, 9x. So let's write some of them and see if we can find something nice. So I know this thing. I can actually just remove the parent rectangle. So this is true. For example, I can also find 4 cosine cube 3x. How can I find it? I will just put x is equal to 3x because this is true for any x. We can say real, or it's also true for complex numbers. So I can just say that cosine 3, so I will put 3x, so this will be just 9x. Or let's say 3 squared x, so this is in parentheses, I want to write parentheses, plus, and this is 3 cosine 3x. Let's write one more, 4 cosine cube. So now I will put 9x. This is gonna be just, I'm just putting, instead of x, I'm putting 3x, so everything is just cancelled by 3. 3 cosine 9x. Okay, cool. So all of these ones have parentheses, but I'm not putting them. So if I keep doing this, so like to calculate this, I can just do it up to k, and then just add the k terms and call it sk, and then I can take the limit as k goes to infinity. So I can just write it for, just generalize it for k, cosine cube 3 to the k x. This is just gonna be cosine. So this thing is just 1 power more. If I go from 2 to 3, so it will be just 3 to the k plus 1 x plus 3 cosine. And this thing is just same, so this is just 3 to the kx. Okay, cool. So now let's look at our series again. So if I just open few terms, so basically I got this thing, I wrote it instead of n, I just wrote k. So now I can just multiply every term by -1 to the n over 3 to the n, which is just -1 over 3 to the n. And then we will see what cancels out. So I can just multiply everything by -1 over 3 to the n. For the first one, I will just pick n is equal to 0. Of course, I will do it on both of the sides. So let's show it like this. So I will multiply both sides by -1 over 3 to the 0. For this, I will multiply both sides by -1 over 3 to the 1 to the 2. So I'm just multiplying both sides by this. And for this, it will be just power k. And if I do that, so let's see if anything cancels. And then I will just add everything. So this will be adding up sk terms, okay? So it will be sk, which is just n is from 0 to k, my stuff. So it was -1 over 3 cosine cube. This is my question, okay? Except I'm adding k terms. So now let's see what cancels out. I have, so this is my left side. I'm not going to touch that. And I also have 4 of this actually. Let's also put this 4. So this is just 1. So I have cosine x. So this is just same. And for this part, I will have -1 over 3. So this means that I can just take this thing, and this is just going to be -1. And this thing is going to be -1 over 3. So I didn't change left sides, but I'm changing it here so that it's like it's not more complicated. For this, I will multiply it by 1 over 9. And this is also 1 over 9, so this will be 1 over 3. And if you look, these two just cancels out. And these two also just cancels out. And you can just do the same. You can write when it's k minus 1. And you can see that just everything cancels out. This one will also just cancel out. So we will only be left with cosine 3 to the k plus 1x. And I have plus 3 cosine x. Cool. So I'm almost done. So now I can just divide all sides by 4 to get like exactly what I wanted. So sk, this is actually sk. Sk is when I don't have this 4. So let's just delete this 4 and put it here. So this is my sk. Sk was just this thing, and it's from 0 to k. My question, let's say question. So this is equal to this stuff. And now if I take this limit as k goes to infinity, let's see what would happen. Can I take this k to infinity? Sorry, I should also have minus 1 over 3. Yeah, it's why I was thinking like, can I take this limit? So I also have minus 1 over 3 to the k here. Okay, now it's better because now, so I have it only for this part. Let's delete this. I have minus 1 over 3 to the k plus this. So now I can just take this limit actually. So let's rewrite it a bit nicer. I have cosine 3 to the k plus 1. And I have, so this, I can just say this is minus 3 to the k. And I have plus 4 and plus 3 over 4 cosine x. So I will just take this limit. Cosine x is just a constant in terms of k. So this thing won't change. This is just a number. So I can just write it 3 over 4 cosine x. So here I'm taking k goes to infinity. And for this limit, I know that cosine x is just between 0 and 1. Cosine, I will, there's also x here. So this thing is just between 0 and 1. Well, this is really easy limit. You can also do L'Hopital, but it's not so useful. You can actually do L'Hopital. Cosine 3 to the k plus 1 x over, so I have minus 3 here. This thing is always between just, I can just take like absolute value of this thing because top part is less or equal than 1. This is always true. And this thing can just be same. I can just say this is just 3 to the k. Or yeah, this is actually equal to that because I'm taking absolute value of it. And this thing of course goes to 0. And anything taking absolute value is also greater or equal than 0. So then I'm done. This limit, sorry, this is not infinite. This is just 0. So this limit is equal to 0. So this limit is equal to 0. I have 1 over 4, so it's still 0. So that's it. This is my answer. So I found that if I add k terms instead of infinitely many, my limit, if I take k goes to infinity, this limit is equal to 3 cosine x over 4, and this is my answer.